Thanks for coming, everybody. I'm, like Jeremy said, Chris Bladon here, your friendly AWS Birmingham, Alabama solution architect. Um, I I guess I should also include Mississippi. Karn and I also cover Mississippi too. Today, like Jeremy said, I'm going to give you a kind of a quickie overview of the AWS serverless offerings and kind of why people are going to serverless and what you can take advantage of and use in your development processes and things like that to kind of speed up your process, get lower costs, things like that. I'm going to apologize a little bit in advance if this sounds kind of salesy. It's not supposed to be a sales presentation. This is supposed to be delivering you kind of like that introductory view of the AWS serverless offerings. So if it sounds salesy, I apologize. It's not supposed to be. It's supposed to be just empowering you and showing you kind of where things are. I was going to do a call out to my young Padawan AWS architect, my son, on the call. He's on the call. He also is working for a startup that's all AWS native in Birmingham. They have they do a fully serverless data analytics pipeline, and for the purpose of they've got a medical device that they sell services around. It's a clinically approved blood pressure device. And they are all AWS and all serverless. So super proud of that company and super proud of Alex. So maybe sometime we can convince him and Preventric to do a little presentation themselves. With that, let's jump in. As far as an agenda goes, I'm going to talk about serverless, and then in the end here, I'm going to try to, if we got time left over, I'm going to try to talk about, or I'm going to try to actually show you a little example of a Lambda function, just super simple. So first of all, why are customers wanting something more than what they have out of sort of existing cloud compute, but even on-premises compute, the on-premises compute environment? And for the most part, what we're hearing from customers is that they wanted to be able to deliver products to their customers faster. So in other words, agility and innovation. They also want to be able to deliver their applications and infrastructure reliably, high availability, scalability, things like that. Obviously, they of course want to deliver with the highest possible security and isolation. And last but not least, they want to be able to deliver all of this with the lowest possible cost of ownership. These are all probably pretty obvious, but we're going to see that serverless technologies just make that even more, that serverless technologies kind of add to this and make this even more possible. So what's the biggest barrier? It's obviously lack of time and spending time on the things that don't matter. We call that at AWS, we call that undifferentiated heavy lifting. AWS, we're constantly trying to get rid of that undifferentiated heavy lifting for you. And that's what, if you look at across the board at AWS services, that's what we're really trying to do. So CIOs always want development teams to focus on innovation and move faster. And today, what we find, though, is that most of a developer's time or DevOps time is spent on operations and maintenance. So this is why serverless adoption is growing so fast. A serverless strategy enables our customers to focus on things that benefit them and not on, again, that undifferentiated heavy lifting, infrastructure management, meaning also patching services and updating versions and things like that. We launched Lambda 6 years ago, and today we've got thousands of customers who have built applications already, and they're driving literally trillions of invocations per month on the AWS Lambda. It continues to grow at a phenomenal rate, but there's more than just Lambda to serverless. The reasons, again, that I talked about are agility, performance, cost, and security. AWS is kind of fortunate here that we've got thousands of, well, I'm just making this number up, but let's say thousands of or hundreds of thousands of years of engineering experience building these applications in the cloud. And and we're doing that by basically learning from our customers. So we're using our customers' experience to then bake into our services all the lessons we've learned from building in the cloud. We take the things that are common across all those cloud applications and we build those into the services, so that all those commonalities either completely disappear or we make them as simple to use as possible. And so, like I said, that means agility, and that's the ability to help our developers and operators move fast. Performance to support as many workloads as possible with horizontal scalability and fault tolerance and disaster recovery. Low costs that follow your usage with the pay-as-you-go model of AWS, obviously, and then built-in, constantly improving security. And we're always investing in these areas, especially in the serverless realm, because we know that that's what it's important to you, our customers. So we kind of start at the evolving paradigm here. At the bare metal, you can see you've got heavy investments into physical capital expenses on your on-premises hardware. Deployments take a long time, and because of all this, you sort of have to be a fortune teller. You got to predict what your usages are going to be like in 5 years, and that all of this creates kind of a slow to innovate environment. Then, if you move up, we've got the realm of virtual machines, the advent of virtual machines. This gives you either on-prem or in the AWS cloud, gives you the ability to have agility and spin servers up quickly. In AWS, gives you breadth of functionality with constantly growing numbers of services. Also in AWS, not so much on-prem, but in AWS, you pay for what you use. Like I said, AWS services, they're globally deployed, making your application available across multiple regions and AZs. And then, of course, elasticity, and meaning no need to plan ahead. For of those costs is typically the discussion starter point, but we actually believe that that agility and innovation are really at the top of that. Really, that's what's actually driving your ability to deploy quickly and safely to your customers, and it gives you that ability to sort of fearlessly build things and then terminate them if they don't work. So it promotes the idea, especially serverless, of just spinning stuff up, trying it out, maybe deploying it out as alpha or beta, or even into production and seeing how it does. And if it doesn't work, you just tear it down really, really quickly with almost no need to do all that forecasting. The third wave is obviously sort of containerization, where you have a high degree of mobility. You're running something on-prem and you want to keep those investments, yet be able to run in production in the cloud. So containers are awesome. They allow you to package your applications and move them between different computing environments. Obviously, it starts a lot more rapidly than a VM does, and you get this whole fancy tool chain that comes with it. But you're still managing servers, you're still updating operating systems and patching them. Lastly, you got serverless. That's the point of the talk today, where you don't have to worry about any of that stuff. And customers tell us that it's that they are going to serverless, like I said, to avoid that undifferentiated heavy lifting. Where too much of their time is spent crawling infrastructure, not enough on the code and the application. This is really where you want to focus your time and energy. You build the code and then you let somebody else worry about the infrastructure. So Coca-Cola, just an example that was cool. Coca-Cola had to react quickly to changes brought on by COVID with their kiosk, a Coca-Cola free drink machine. They wanted to provide a touchless experience for that machine, and they wanted to build a smartphone app that allowed customers to order and pay for drinks without touching their vending machines. So they built that with Lambda, and their team was able to focus on the application rather than all the security and latency and scalability, because that's what Lambda is all about. As a result, they built this new application in 100 days, and now over 30,000 machines have this touchless capability. It's super cool. So let's talk about building new applications. you kind of see a progression of adoption of serverless. And this is probably what you will probably do too if you adopt serverless. It can sort of take different paths, but you'll often see that people start with IT automation. So they'll start with using Lambda functions to, say, validate configuration or interact with an EC2 machine or respond to events that, say, you're dropping in S3. So that's almost always where you'll kind of start, because it's the part where it's kind of like the easiest to do and you get a lot of bang for your buck. Next, you've got teams who are start building integrations, like I said, with S3, with Kinesis, with Kafka, in order to build data processing applications. So this gives you huge amounts of power, and it converts you over from using a batch processing environment to now using a streaming data, an automated streaming, say, data pipeline, or a pipeline operation around your data. As your experience kind of expands, then you'll get multiple teams then starting to build, say, microservice-based applications, typically for web apps. And then finally, the kind of capper on all that would be using Lambda functions in your machine learning applications. So one common theme across all of these is that serverless applications are sort of built to follow the ideas of the internet and the web. So small pieces joined together loosely. All these applications are modular. They're composed from multiple AWS services, and then also customer developed components. So that's why we're focused on the integration side, because of that's kind of like the starting point, like I said. So Lambda, Event Bridge, API Gateway, step functions. That's like the kind of first little step into this like serverless arena. So if you're looking to get in, those are probably your first function, the first serverless offerings you're going to look at. We want to make it easy for you to build applications and functionality through that loose coupling with other components too. That often starts with APIs managed by API Gateway, sort of like what we kind of call the application front door. And often events and messages are the communication system in the back end with coordinated workflows. So let's look at just all the AWS serverless offerings. I mean, this isn't even all of them. This is just a few of them, really. Most people associate Lambda with serverless, but there are actually many services at all layers of the stack. So while Lambda offers many of the key advantages that customers are looking for out of serverless, it's really when all these other components surrounding Lambda are involved that we really see the bigger benefits. So if you take a look here at the slide, at the top, at the computing level, you've got Lambda, the obvious one, and hopefully, like I said, if I got time, I'm going to show you a little Lambda function. And then you've got AWS Fargate, which is our serverless container system. And so for those of you who are big container people, that could be the starting point for you to get into the serverless world. So the ability to run containers without spinning up and provisioning any kind of backend EC2 instances or anything like that, where you're maintaining operating systems and you're patching and you're SSHing into the machines and things like that. There's none of that with AWS Fargate. So this, with Fargate and with Lambda, this gives you the ability to really talk at the level of sort of the business functionality, where you're talking scalability and reliability and things like that. At the data store level, we've got Amazon S3. A lot of people, everybody on the call probably knows what S3 is, but you don't think of S3 as being serverless, but it really is the serverless sort of data store of AWS. All that Event Bridge stuff that I was talking about, and the ability to, say, drop files into S3 and use those to trigger, say, downstream data pipelining and things like that. All that goes into the S3 serverless offering. Amazon Aurora Serverless. If you haven't looked at Aurora and Aurora Serverless, you should definitely do it. I should probably do a talk on those just themselves if people are interested in that. Aurora Serverless is super cool, and it gives you the ability to basically have a serverless database, which is, if you think in terms of a MySQL database, for example, it sounds like science fiction, but it's super cool to play around with and use. And then Amazon DynamoDB, our managed serverless NoSQL database. And again, same deal. If you haven't used DynamoDB, it's definitely something you should look at, especially if you're writing brand new applications and you want a backend data store that's in NoSQL, so very friendly to development, and very, very high speed. Because it's serverless, it's a provision server, will go almost as fast as you want it to go. So again, super cool in the data area. On the integration side, you've got EventBridge, which is the event system that is the system that kind of is communicating between all these services. And so say, for example, you want to send an event when an S3 file is dropped, or a file is dropped into S3, and you want to trigger an ingest into Amazon Aurora Serverless, or an ingest into DynamoDB, or you want to trigger a batch process or something like that. There's a million different possibilities. That's where EventBridge comes in. Amazon API Gateway. This is our serverless REST API system. And that's the thing that I'm going to actually talk about next session. I'm going to show a full application developed in API Gateway with Lambda and DynamoDB. So that's what I'm going to walk through next time. Amazon SQS is our simple queuing service. Amazon SNS is our simple notification service. That's email, SMS, things like that. Step Functions is our serverless workflow orchestration service, and then we're showing here AWS AppSync, which is our serverless managed GraphQL service. There are actually other services that are serverless here that are not even shown on here, probably because they're more recently announced than this slide was updated. But one of the biggies is Redshift serverless. That's also super cool for data warehousing and for high-speed analytics using a serverless offering, which is like also very exciting and fun to use. And also in the data area, you've got Amazon Athena, which is the ability to do SQL queries over the top of somewhat unstructured data in S3, like in CSVs, JSON, and Parquet, things like that. So if you want to be able to do those kind of ad hoc discovery-based queries over S3, Athena is the thing for you to look at. So, so for many customers, you've got this decision about which of these technologies to use. If you kind of look at here at the bottom, you start at the bottom, you've got EC2, you got access to all the knobs that you can twiddle to make everything exactly how you want them. Or at the very, very top, you can go completely serverless with Lambda, where you're focusing just on your application. So really, all the time when you're deciding what technologies you're going to use, EC2, ECS, and EKS, which are the Elastic Container Service and Elastic Kubernetes Service, the AWS Fargate Serverless, or at the top, Lambda, it's always this trade-off between how much you want to manage and how much configuration control you want to have over that. So there's really no right or wrong answer here. It's not that Lambda or Fargate or whatever are always the right answers. It's more about what's the right thing for your particular application that you're trying to deploy. So again, you're always kind of making that decision, and sometimes EC2 is the right answer, and sometimes Fargate is the right answer. You know, it just depends on what your application is. So just kind of an example, one of the benefits of Lambda is that it responds to data in near real time. So it allows you to kind of do those real-time data pipeline operations that, like I said, are a lot of reasons why people get into the serverless technology. It makes that it makes that high-speed data processing very attractive and very easy, and it doesn't, and it sort of gets you away from the sort of batch file drop architecture. So Nielsen Marketing Cloud, they're doing this at an incredibly high rate. They're using Lambda to process 250 billion events per day, which is just unfathomable. All the while, they're maintaining quality and performance and cost using this fully automated serverless pipeline. The scale of it is just amazing, and that's really why they went to this architecture. On a peak day, Nielsen receives 55 terabytes of data with 30 million Lambda invocations, and they're handling this with absolutely no problem. They have recently hit up to 3,000 Lambda functions running concurrently, so that's even pretty impressive. On normal days, they say between 1 to 5 terabytes of data, and they're able to scale their in order to meet this need without additional work. The system sort of just automatically scales. So that's another advantage, by the way, that I didn't say. You can start really small. If you're a small shop, you're a small startup, you can start really, really small, and this thing just scales as you do. So it scales as your business does. So again, that just kind of lets everybody breathe a huge sigh of relief when you build something in serverless. And Nielsen passes all this data into their ad network, their advertising partner. So that's what this kind of like, what this whole system does. It's really like a processing system to process all this data and to pass it to their downstream partners, and all these Lambda functions in here are built in order to actually do that. They also use something that will come up when you build a serverless offering. Is you'll see that rate limiting and throttling is an important part of your decision-making process when you provision these. So you're choosing how fast you want the data to go through, because one of the issues here is that you can, like if you push data through and you tell this thing you want it to go fast, this thing will go as fast as it possibly can. And sometimes you don't want that exactly. You want to be able to slow the thing down a little bit and provision it so that, say, for example, for cost, if you want to provision it for cost, or you want to provision it so that your customers, if they're hitting APIs, that they can only hit the APIs at a certain speed. So all that's important in the provisioning and the building of your system. And that's, again, the beauty here is that all these services give you the ability to actually do that. So APIs, quickly here, everybody knows the APIs and microservices are sort of the way to go here. This is just showing an example of how Realtor.com has their APIs set up. This is fairly obvious, but you've got web requests coming in through the internet, going through CloudFront, that's our content delivery network, and going into API Gateway, which has the ability to cache up here on the top, and it can be monitored through CloudWatch. Here is showing a Lambda function and writing data into an image repository in DynamoDB. And actually, API Gateway can communicate straight into DynamoDB. You don't even have to go through a Lambda function. It's got integrations straight into Dynamo. So events, like I said, are the kind of connective tissue between all these serverless offerings. This is probably fairly obvious, so I don't want to spend huge amount of time here, but you're typically designing for events that are asynchronous, so you don't need to wait for a response to move on to the next step. That's going to improve your resiliency and reduce your dependency, your interdependencies between your services. The tools of event-driven architectures are the routers and the consumers, the routers and the producers and consumers of each of these services. You can publish events and consume them in other services without the knowledge of each other, so without the dependency. Event routers at AWS include Event Bridge and the simple notification service, SNS. You can also use event stores that act as buffers, holding on to events until the consumer is ready to use them. So that would be something like SQS or Kafka or something like that. Now, at Kafka, I didn't mention, but we also have a serverless offering of Kafka too. If you're into Kafka, we've got a managed Kafka service, and we also have a serverless version of it. So, so from the perspective of producing events in a serverless way and using queuing between your services, this is kind of like how you handle that asynchronicity, between your services, and to actually decouple your services from each other. In the case of Amazon MQ, another queuing service, it has standard API protocols like JMS, NMS, MQTT, WebSocket, things like that. So Lego uses an event-driven architecture. They in 2017 they had built on AWS kind of a big monolith to handle their checkout event process, their checkout system on their store, and they had after a particular Black Friday, which I guess was in 2017, they had a crash. So they were looking for something more scalable. So they began the decoupling on their back end, and they ended up with an event-driven serverless architecture. And we used a lot of what they fed back to that. It fed back to AWS as knowledge that we fed back into our services, and that's what actually led to the advent of EventBridge. So EventBridge was the perfect hub and spoke model for what they were trying to achieve, and so that's why we built it into our EventBridge product to offer to everybody. So Lego rebuilt their entire checkout process using EventBridge, and in this way, rather than building point-to-point connections between services, then they had this much simpler way of using events to build the integration and to build the asynchronous event processing that they use in their system to get that scalability. So the last kind of big piece, I think, that is part of that I mentioned in the beginning is step functions. So so it's pretty common for cloud applications to be composed of multiple services and components, and as your application grows, you start writing an increasing amount of code to coordinate the interaction of all these components, especially when they're asynchronous calls, where you're calling them and you're waiting for a response, and you don't, and that response can be slow. And if you need to incorporate user input into that, or actual human input into that workflow, so that's kind of where step functions come in. So step functions, it's a managed. This is where a managed workflow it allows you to focus on the component interactions. So you're building those workflows for the interactions, but you're writing your software really to in these little pieces to enable each step of the workflow. So here you can see this is an example of one where a client is making a client application is making a REST post into API gateway, and that API gateway is then kicking off a workflow where it's using Amazon Comprehend to do a sentiment analysis on the data that was put in by the client, and then it makes a decision if the sentiment is good or bad, and then if the sentiment is bad, it sends an email using the Amazon Simple email service. So it's just a really, really simple example. Your examples will probably be more complicated, obviously, but this gives you the ability, especially the way I put it is, we are calling remote services, again, where the time, where that call has like an asynchronous kind of nature to it, where you don't know how long it's going to take to run. It could take 5 or 10 minutes to run it, for example, or it could be even longer. And especially then where you're bringing in user input as part of a workflow. So all those are great uses for AWS step functions. So when you're replatforming, that's a slightly different use case. You're not building from the start, but there are a few technologies that you can kind of help when you're replatforming. I kind of mentioned them already, but you've got the ability to actually run services that you're typically using already right now, maybe on-prem or in the cloud. You have the ability to bring those in and integrate those in with the serverless offerings. So you've got, like I said, Amazon MQ. You've got the managed Kafka service, or now the serverless Kafka. You can also do Amazon managed workflows with Apache Airflow instead of using step functions. So lots of these are just 3 examples of the ability for you to kind of re-platform onto AWS and run the services that you're already using now. In fact, and then finally refactoring, the last kind of like thing. And I'll just kind of show really quickly what a typical refactoring might look like. We have a traditional 3-tier application architecture: web server, application server, and a database server. And you want to refactor that now into a serverless offering. You'll see it has the kind of look of a 3-tier. It's sort of got 3 tiers here. You've got your presentation tier, but instead of your kind of web app middle tier business logic, now you've replaced those with some of these serverless offerings we talked about. You might have Lambda responding to events through Event Bridge. You might have API Gateway in here responding and building or offering REST services, and you might be using Fargate for your serverless container platform. Those in the middle tier then are communicating, say, with other serverless database offerings. So here we're just kind of showing 3 here, but like Aurora, DynamoDB, or something like that. These are all giving you the ability to have serverless databases now, and it gives you the choice in the back end of what that database representation might be. You could, you don't have to, you're not even stuck to using one particular database. You can use multiple types of databases to fit the right use case that you have, high transaction rates, or maybe analytics or something like that. So one of the most kind of important and sort of the last kind of pieces that you'll consider is the security side. You can look at this as a philosophical approach. You can choose on the left-hand side, sort of security free for all. Let everybody just develop whatever they want, and then on the right side you can have complete lockdown, centralized control. Neither of these two are really prescriptions on how to do things. That free for all is probably not the right choice, but I've got it here just to show what the kind of full spectrum is. AWS's kind of philosophy is to kind of sit somewhere in the middle and allow you to choose what that how fast and loose you want to get, and choose how much you want to essentially control. So we're just enabling you to make all those choices yourself. There's no one kind of choice, but obviously, the trade-off here is you want to let your developers and your DevOps people move as quickly as they can. So you want to give them the freedom. So that's like a decentralized model. But at the same time, you're also trying to use you want guardrails and the kind of centralized management and control setup as well. So again, this is a choice that AWS lets you make yourself in order to accommodate or to accomplish your particular business goals. So just to wrap up here, I'm just looking at time here, just wrapping up here. Serverless, again, is all about innovation. Our goal is to help you innovate. We think that the serverless is that the serverless services that we offer are the fastest to market, lower and the lowest total cost of ownership. And when we think about where and how to innovate, we do it based on your feedback. So it's something that I always remind everybody, and this crowd especially. We build our services on what y'all tell us that you need. So if I have the ability, I can put feature requests straight into engineering. So if y'all find things that you need out of AWS, you let me know, and I will get those in there. And and the more people that are interested, the higher priority we can make those. So this platform is always evolving. It's always something that is there for you to to give us feedback on and to build. So again, serverless, we're trying to drive the agility with Lambda. We've got OCI support in Lambda functions for running containers in Lambda functions, all kinds of cool stuff in there. We're trying to obviously trying to go for performance here, highest value. So we're trying to lower your total cost of ownership and give you the ability to drive as much business value out of you and deliver to your customers. And we have hundreds of integrations into our own services, but not only our own services, but into third-party services as well. So with that, I've got enough time. I think I'm going to show you, just for giggles here, I'm going to show you what a Lambda function looks like. I'm just going to craft up a Lambda function for you in front of your very eyes, and then hopefully I'm going to leave just a little bit of time for questions. So what I'm going to do right now is I'm just going to create a little Lambda function just to show you. Let's see now. Now, somebody jump in. Can you actually see my console home, or am I still showing my? Am I still showing?
We see your console.
Oh, good. Okay, awesome. Okay, good. Just want to make sure. So what I'm going to do, I'm in the console here, and I'm going to drop into Lambda. Now you can also navigate there by just typing in Lambda up here and hitting return if that's easier for you. And I'm just going to create a Lambda function here. So I'm going to create that Lambda function. I'm going to do it from a blueprint just because that's going to be the easiest way to go. So I'm going to click on blueprint. I'm going to search here for hello world. This is a great way to get started. Even if you're not going to do a hello world, you can use this just as the template to get you started. So click on hello world. There's my hello world. It's a Node.js Lambda function. So I'm going to click on that and choose configure. I'm going to call it AWS Meetup Lambda. And I'm going to just create, I'm going to just have AWS create all the IAM permissions and everything for me because I don't want to mess around with that. It's actually faster and easier to use an existing one that you've already done, but I'm just going to have it create just for the ease of configuration. And then I'm going to use this little code. This is the code it's going to generate. That's the whole Lambda function right there. And I'll show you that. I'm going to hit create here. And as we're looking at that, you can notice that what it's doing is it's just doing a bunch of console logs. That's basically all it's going to do. So our Lambda function just got created, and here's our code. So this gives you like a little kind of baby development environment here for developing your Lambda function. So it's handy and useful for this kind of just free-form discovery of the Lambda system. And I'm just going to modify this a little bit. I'm gonna keep that log event where I'm just going to log the event that's coming in. The event is like the input parameters that are being passed into this Lambda function. I'm going to get rid of those console logs. These comments aren't going to match, and I'm going to return a piece of JSON that I'm going to call the message, and I'm going to say hello world in typical old C style. If you were writing your first C program, and that's basically it. That's our Lambda function. So I'm going to log to the log our event that's coming in, any kind of parameters that we're passing in, and then I'm going to just return as a JSON message. I'm going to return hello world. So I'm going to push deploy here. That's going to deploy it out as a Lambda function that's able to run. And now, just to show you this before I actually run it, I'm going to go over here to this test functionality. This gives us the ability to actually test it right here in this little in this little UI. I'm going to create a test event here, and I'm going to keep these. I'm going to keep this little JSON test event just for giggles because I'm not really using these, so I'm just going to save that. Now from right here, what I'm going to push test, and what it's going to do is it's going to pass this JSON event into my Lambda function. Lambda function is going to run, and it's going to return a result. And you'll see here, right here is the result. Here's the result that there's the JSON it handed back. And here down here is the log, the entire log of the start and finish of the Lambda function. And you can see right there, there's my console log of that event that came in, and that's those 3 values of the test event that I passed in. So really, really cool, really, really handy to be able to develop and just play around with the Lambda system. This gives you, just the quickest ability to build stuff, and you can just build your stuff right here. Now, there are much more advanced ways to build your Lambda function. You can have the ability to integrate this into your IDE, your favorite IDE. You've got there are integrations with Eclipse and IntelliJ and VS Code, all kinds of different things. But if you're just playing around, this is kind of like the easier way to do it. You can monitor the invocations here under this monitor tab. And this is really just bringing in the data into this UI from CloudWatch. So this shows you how many invocations you've done over the past, I don't know, whatever, couple hours. This shows you how long each Lambda function lasted when it ran. So these are actually running very quickly, under 23 or 93 milliseconds. And some of them are down here after the Lambda function cold starts. They're way down here in time. You can see errors that have occurred here. You can see any throttlings that have occurred. So where you've intentionally provisioned throttling so that, say people can't abuse your APIs. So this is how you would kind of debug your services and then monitor them. Last thing I want to show is you can instead of actually develop, well, not the last thing, you can actually develop code and upload it as a zip file. So for example, under code here, we'll go over to code, and you can choose to upload your code from a zip file straight off your machine if you want, but you can also pull it from an S3 location. And this would be typically how you would do it if you were in a code deploy environment. You can use AWS code deploy and code build, and you can actually build the code and upload it into a Lambda function, all from the automation perspective. Again, this is actually just showing me now the last invocation that I did here. So again, the ability to sort of debug this. I was going to show you two. Yeah, we're looking pretty good on time. I'm going to show you one other thing, super duper cool here. This is a new capability that was added. It's the ability to actually call your Lambda function straight from an outside URL. So before, you always had to invoke your Lambda function either through this test API or via some internal or from some other AWS service. So you could trigger it from an event bridge. You could trigger it. You can call it from API gateway. You can use it as a trigger in DynamoDB. But in this particular case, we now have the ability to create a URL that will just call the Lambda function straight in. So I'm going to show you that right here. I'm going to create a URL for this Lambda function. I have a choice here if I want to use AWS IAM as the authentication system. So if I want to lock this down so that only people who are authenticated into IAM can actually call it, but I'm just going to open it up to the world. Not really super advisable, but I'm doing that here because this particular function isn't going to, it's not like it's actually doing anything, and for the purpose of showing you how this works. Now you could actually use this, but I just advise a lot of caution if you're actually developing systems and opening them up to the world like this. This is probably not super safe, just from your own perspective. But I'm going to do that here because again, there's no risk here. So I'm going to build this function, and it's going to create that. Now I've got my URL, so you can see it's kind of it's a little obfuscated by this this like hash code here that is giving you. Just because it's obfuscated doesn't mean that people can't discover it. It is discoverable because that little ID right there is actually a hash of a combination of sort of public thing. So you can determine what that is. So I'm going to just click on this. I'm going to look in a browser and we're just going to invoke the function from the URL. So what I did is from Firefox, I hit that URL, I called my Lambda function, and it returned this JSON message, hello world. So again, super cool. And it give and so this is kind of probably your first foray into serverless. It gives you hopefully what I have done here is just give you a little bit of a taste of what serverless kind of looks like. Serverless is it's just a really fun thing to do. So I encourage all of you to go out there, start playing around with this, build little functions. You can build little REST services, you can build integration, you can build little data pipelines. It's just super fun. And it kind of, it makes you kind of, it'll put a smile on your face how fast you can actually develop things, where before you were spinning up EC2 instances, spinning up web servers, spinning up app servers and Tomcat and all the kind of stuff that you did before. That's just all that undifferentiated heavy lifting. So with that, I'm gonna, I will say thank you, everybody, and I'm gonna open it up for the floor for any questions or comments or anything that people want to ask, or anything that people are even thinking about building. Why don't you throw it out here and we'll sort of talk about it. I know I kind of just threw that at everybody.
Thanks, Chris. Yeah, definitely an awesome demonstration. I think probably the better question is what sort of, would be great to hear what ideas for anybody who hasn't done this yet, any thoughts or ideas of application for some of what you've seen?
Yeah, like where people feel like they think it fits in with what they're kind of doing, maybe, yeah. I think I've stunned everybody. I've stunned them all into silence.
Well, this was a really strong primer today. Everybody keep in mind, Chris is going to be back with us next month for the May 26th meetup to go into this in even more depth. So send us your questions, after the fact, or thoughts of things maybe that you would like to see baked into the follow-up on this session when he walks through.
Yeah.
For the whole ecosystem, it would be great to have your input and your thoughts on what you'd like to see in that. And, as always, reach out to us with any follow-up questions.